Yeah, as long as you don't look near the sun. Look, we got shade things in our cars. What happens? The sun gets in our eyes. We put the shade thing up, we can see perfectly.
Yeah.
I got my thing here. It's mentioned in my book. It's a blackened tube.
Mm-hmm.
I can shine a flashlight down it at night, right, and still see across and see the stars.
Yeah.
I can use it in the daytime with the sun streaming down that big barrel. Look right across it and see a black roof 10 miles away. What the f*** are they kidding? All you had to do is put your hand up there and shield the sun.
Returning to the interrogations, Lovell was asked some more serious questions. These questions regarded the most incriminating evidence against him.
But the biggest reason is the plain simple fact that if you can't possibly go somewhere without dying, you couldn't ever have gotten there. It was impossible to go to the moon because of a thing called radiation in space. Now that's been the hardest thing to gather information about.
A publication that Renee picked up on was an article by Dr. James Van Allen, published in the March 1959 issue of Scientific American.
The article's titled Radiation Belts Around the Earth. This is James Van Allen, the discoverer of the Van Allen belts. And it was real clear and simple. One of the statements he made about that time was that space was a sea of deadly radiation. And how did he figure this out? Well, he was using things called raccoons, and he'd have a high altitude balloon take this rocket as high up as it could, and then he'd fire the rocket. And he was getting in outer space. Wanting to know more about it, one day they put a Geiger counter in as a payload. And they watched that Geiger counter go up, 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 and then fall flat dead. No more transmission. They figured the machine failed, so they sent the next one up with a Geiger counter. They did the same thing. So one of his assistants, I think it was, said to him, hey, look, why don't we take another Geiger counter and shield it with lead so that it starts to count where the first one seems to have failed at the end of the scale. Now remember, the first one passed through the red scale. What does the red scale indicate? You can't be there.
After extensively sending up Geiger counters into the belts, Dr. Van Allen had this to say.
Our measurements show that the maximum radiation level as of 1958 is equivalent to between 10 and 100 roentgens per hour, depending on the still undetermined proportion of protons to electrons.
He goes on to say that,
unless some practical way can be found to shield space travelers against the effects of radiation, manned space rockets can best take off through the radiation-free zone over the poles.
According to the US Sentinel Flight Commission, the radiation levels of the Van Allen belts are 100 million electron volts. Years after the outcome of the trial, when Sunspot NOAA 720 exploded, NASA would go on to admit that protons of such energy level could penetrate 11 centimeters of water, and that astronauts caught in this proton storm would have shown symptoms such as vomiting, fatigue, and low blood count. These kinds of symptoms occur at 100 rem. During these interrogations, Lovell admitted that the hull of his spacecraft was only 3 inches thick. With Van Allen's statement in mind, Lovell was asked, isn't it true that radiation received by a ship passing through the belts can be as high as 100 rem per hour? Lovell committed to perjury by denying Van Allen's research with the following quote, "It is not true that the radiation received by a spacecraft was as high as 100 rem per hour. The attached summary of the Apollo 13 post-flight crew brief indicated that they were in the vicinity of 2.27 rad per hour." He also denied that he was within the belt for an hour each way, even though all the propagandists insist that the Apollo astronauts passed through the belts within an hour or more. Many of these propagandists usually love to point that the passage through the radiation was in the outer belt, the supposedly less intense of the two belts. However, when Van Allen sent his Geiger counters into the outer belt, they registered the highest levels of radiation. In the March 1959 Scientific American article, Van Allen summed it up in these statements.
On October 11, 12, and 13, Pioneer 1, the first lunar probe, carried our instruments nearly 70,000 miles out from the Earth. Though its readings were spotty, they confirmed our belief that the radiation extended outward for many thousand miles, with its maximum intensity no more than 10,000 miles above the Earth. The inner belt reaches its peak at about 2,000 miles from Earth. The outer one at about 10,000 miles. Beyond 10,000 miles, the radiation intensity diminishes steadily. It disappears almost completely beyond 40,000 miles. The maximum intensity of radiation in each belt is about 25,000 counts per second, equivalent to some 40,000 particles per square centimeter per second.
When asked about the altitudes for these peaks, Lovell simply replied, "This question is beyond my expertise."
The original Geiger counters had been overwhelmed by an enormously high level of radiation. Subsequent to my writing the book, he retracted. Gee, I wonder why. And I used to write him and say, look, for Christ's sake, you're getting older by the day. You want to die with this shit on your conscience? And now he says, well, maybe we made a mistake. Geiger counters don't make mistakes.
It's important to note that the lead shield they put around the Geiger counters to obtain these 100 rem per hour readings in the first place was only 1 millimeter thick. Earlier this year, on the Penn and Teller radio show, Phil Plait had this to say about the radiation shield requirements.
And, you know, you hear these claims, the astronauts needed 8 feet of lead to prevent them from dying from the radiation. And that's wrong, too. There's different kinds of radiation, and the kind of radiation that is in the belt is actually stopped pretty well by the insulation in the spacecraft and the suits they were wearing.
What Plait does not reveal on radio, or TV, or on his website, or in his book for that matter, is the individual who René sourced for meters of shielding. During his research, René picked up on a book entitled Prospects for Interstellar Travel. It was written in 1992 by Dr. John H. Malden, who holds a bachelor's degree in engineering physics, a master's in physics, and a PhD in science education. He has taught physics and engineering at several colleges and universities, and during his time at NASA, Malden worked in electronic power engineering for the Voyager program, which pushed probes all the way out to Neptune. On page 226 of his book, one comes across the following statements.
Solar or star flares of protons, an occasional and severe hazard on the way out of and interplanetary systems, can give doses of hundreds to thousands of rem over a few hours at the distance of the Earth. Such doses are fatal and millions of times greater than the permitted dose. Cosmic particles are dangerous, come from all sides, and require at least 2 meters of solid shielding all around living organisms. Earth's atmosphere provides the equivalent of 10 meters of shielding. By comparison, solar flares can deliver GeV protons in the same energy range as most cosmic particles, but at much higher intensities. Increase of energy accounts for most of the increased danger because GeV protons will penetrate several meters of material.
It seems Malden is not the only one who proposes meters of shielding for space radiation. More recently, René has picked up on the research of Gene Parker. Parker is the world's leading expert on interplanetary gas and magnetic fields, best known for hypothesizing and explaining the solar wind back in 1958. Although he agrees with Malden that the yearly radiation dosage below the Van Allen belts is 10 rem per year, Parker is apparently not satisfied with Malden's 2-meter shield proposal.
If the material is water, it has to be 5 meters deep, so a spherical tank encasing a small capsule would have a mass of about 500 tons. Larger, more comfortable living quarters would require even more. By comparison, the space shuttle can only carry a maximum payload of about 30 tons.
In addition to his 5-meter material shield, Parker also proposes a ship with its own magnetic field, or a ship with an electrostatic charge to repel away cosmic particles. Interestingly, Parker claims that the latter was proposed for a moon base. It cannot be overlooked that the cosmic radiation Parker is talking about has an energy level as high as 2 billion electron volts. And we know that the cosmic radiation that strikes the Earth from all sides has energies of 10 billion electron volts. Probably the most damning statement from this article comes from a caption that Parker gives one of his diagrams.
Solar flares and Earth's Van Allen radiation belts can kill outright, but are easier to avoid.
I can't help but wonder who gave him the idea that they were easier to avoid. Mr. Windley, who would have us believe that Malden's shield is not required for an exposure over a few hours at the distance of the Earth? Or Mr. Olberg, who assures us that one can stop this radiation simply by putting the bulk of the service module between the crew and the incoming radiation?